Okay, solving rational inequalities is what we're going to be talking about today. There's lots of how-tos here, and that can get a little confusing. So basically, listen to my voice. I'm going to take this example. I need to look at my answer as an inequality, and I need to kind of do the same thing that I've been doing in terms of solving an equation or an inequality. I need to set these equal to 0. And then I need to find some critical points by maybe, combining some like terms, getting common denominators. And then once I find those critical points, I need to place them on a number line and do some checking. You cannot rely on these to be the same as the quadratic inequalities, as you will see when we do the checks. So, number 1, I'm going to subtract 5 from both sides. So I'd have x, make sure, over x minus 1 minus 5 over 1 is less than or equal to 0. So I'm subtracting 5 from both sides. Then I'm going to say, all right, I want to combine the left-hand side, so I need a common denominator. So my common denominator looks like it's going to be x minus 1. So I'm going to multiply 5 over 1 by x minus 1 over x minus 1. When I do that, I get x minus...
Please excuse this interruption. At this time...
And I have minus 5 times x minus 1. So I'm going to make that like that. And the entire denominator is x minus 1. Then I'm going to distribute that numerator, so it's x minus 5x plus 5. And lastly, to clean this up, looks like negative 4x plus 5 over x minus 1. So, what we have here is a different way to kind of look at the factors. We've got kind of like a factor in the numerator and a factor in the denominator. Those are going to give us our critical points because so what we're going to do is take negative 4x plus 5 and set that equal to 0 and x minus 1 equal to 0. And when we solve that, we get negative 4x equals negative 5, x equals 5/4, and x equals 1. So our critical points are 5/4 and 1. So what I'm going to do is place those on a number line. So if we think about it, if you let x be 1, then you replace x with 1, you'd get 1 minus 1 is 0. That's undefined. Okay, so we have to put an open circle at 1. But if we let x be 5 over 4, in the numerator, you would get negative 4 times 5 over 4, which would be negative 5 plus 5. In the numerator, if you get 0, that's fine. In the denominator, it doesn't matter what the value is. 0 divided by that would be less than or equal to 0. That would be true. So 5/4 gets a closed circle. Now you might think it's an and, but we need to check it because it is really not. So I'm going to check 0. And when I check 0, I get 0 divided by -1 is less than or equal to 5. That means 0 is less than or equal to 5 is true or false. That is true. So my solution points that direction to the left. It is not an AND or a conjunction. If I check, let's say 2, which is larger than 5/4, and I'm checking in the original problem, 2 over 2 minus 1 is less than or equal to 5. I get 2 divided by 1, which is just 2, and that is also true. So this is really the direction that the solution's going. It's an OR. So the answer is x is less than 1 or x is greater than or equal to 5/4. And if you look at the graphing calculator, -4x plus 5 divided by x minus 1 and then y2 equals 0, you will see that the values are less than 1. Okay, here's 1, and it's hitting at 5/4 here, and so they're getting larger than 5/4 as you go to the right. Okay, those are all the solutions. So these are a little bit different. Okay, so that is somewhat explained. I do my checks in the original problem. That's somewhat explained in the procedures. That's, at this point, I think the easiest thing to do. Next year when you get to pre-calc, you will be doing your checks a little bit differently. Let's take a look at the next example. Okay. So you can look at the graph to verify your solutions, but let's solve it algebraically because that's what you're going to have to know how to do. So I'm going to take 7 over 2x minus 2 over x minus 3 over 2 is greater than 0. So I'm subtracting 3/2 from both sides. My LCD is 2x. So I'm going to multiply this one by 2 over 2 and this one by x over x. And not going to drop any denominators here. Now I'm going to combine. So I have 7 minus 4 minus 3x all over 2x. And 7 minus 4 is 3. So I have 3 minus 3x over 2x. So I'm going to find, so that's as much as I can simplify it down to. So I'm going to find my critical points by setting 3 minus 3x equal to 0 and 2x equal to 0. So I'm looking for what will make the numerator 0 and what will make the denominator 0, because those are the critical points. And then to decide what the answers are, I'm going to look to the left, the right, or the middle and do a number line check. So I get -3x equals, if I subtract 3, -3, and divide by -3, x is equal to 1, and divide by 2, and x is equal to 0. So my critical points are 1 and 0. So now I go and I place them on the number line. Now, if I take in the denominator and put 0 down there, it's going to be undefined. So open circle. If I take 1 and put it in the numerator, I get 3 minus 3 times 1, that's 0. But 0 is not greater than 0, so they're both open circles because it's greater than and not greater than or equal to. So you might think it's an OR, and that actually is not true. So let's do some checks. Easiest things to check would be 2 and say probably negative 1. So 7 over 2 times 2 minus 2 over 2 is greater than 3 over 2. So 7/4 minus, now I'm going to just convert this to fourths. So I'm going to multiply this 2 halves and make it 4 over 4. And then is that greater than 3 halves? So 7 minus 4, so is 3/4 greater than 3 halves? No. So 2 is not part of the solution. And if I check negative 1, I get 7 over 2 times negative 1 minus 2 over negative 1 is greater than 3 over 2. That's negative 7 over 2 plus 2 over 1 is greater than 3 over 2, which is negative 7 over 2 plus 4 over 2. And that's negative 3 over 2. Is that greater than 3 over 2? No. So it is an and. And the answer then is 0 is less than x is less than 1. And you can look at the graph to verify the solution. Okay, so x needs to be between 0 and 1. Kind of hard to see that here with the graph the way it is. All right, let's take a look at number 3. Okay, so for number 3, we have 2 over 1 minus 3 over b is greater than 5 over b plus 2, but I'm going to subtract that. So I'm just going to do that right away and make it minus 5 over b plus 2 is greater than 0. And my common denominator looks like b times b plus 2. So this one needs b times b plus 2. This one needs b plus 2. And this one needs b. Okay? So now all those denominators are the same. So I have b times b plus 2. Actually, I have 2b times b plus 2 minus 3 times b plus 2 minus 5b. And that's all over b times b plus 2. Because right here you're multiplying 2 times b plus 2. So now when we distribute that, we get 2b squared plus 4b minus 3b minus 6 minus 5b. And that's all over b times b plus 2. So that's 2b squared. 4b minus 3b is 1b minus 5 is minus 4b minus 6. And that's all over b times b plus 2. And that can be factored. Factor out a 2, and you get b squared minus 2b minus 3 over b times b plus 2, which equals 2 times b plus 1 and b minus 3, all over b times b plus 2. And that is greater than 0. So now our critical points are when we take b plus 1, b minus 3, and b plus 2 and set them equal to 0, and b as well. So our critical points are 0 and negative 2 from the denominator, negative 1 from the numerator, and 3 from the numerator. I get those from setting b plus 1 equal to 0, you'd get negative 1, b minus 3 equal to 0, you'd get 3, and same thing with the denominator. So what I have to do is set up a number line here. Check. Kind of running out of room. So I would have the smallest, then negative 1, then 0, and then 3. This is a crazy one. Okay, so they're all going to be open circles because it's greater than 0. It's not greater than or equal to. I don't have to worry about that. So now we should probably check negative 3. So in the original problem, it would be 2 minus 3 over negative 3 minus 5 over negative 3 plus 2, which is negative 1. Oh, I'm just doing the one I solved. That's okay. So I'd get 2 plus 1, really, plus 5. Well, that's true. So I know that it's going in this direction. So negative 3 is part of the solution. And then, let's see, another one I could check. Let's check 4 over here. So that's going to be 4 minus 3/4 minus 5 over 4 plus 2, 6 is greater than 0. So let's make this 12. So 4 times 12, 48. Okay. And then 3 over 3, so 9/12, and then 2 over 2, 10/12. So 48 minus 9 is 39, minus 10 is 29/12, and that is indeed greater than 0, so we know that the direction goes this way. So then what we have to do is figure out what's going on in the middle. So usually if they're connected this way, they're not connected between 0 and 3 and negative 2 and negative 1, so I'm going to also check point negative, well, I need to be between negative 1 and 0, so I guess I have to check negative 0.5. So for that one, I have 2 over 1 minus 3 over negative 0.5 minus 5 over negative 0.5 plus 2. Okay, so when I check that out on my calculator, 3 divided by 0.5 is 6. So this becomes 2 plus 6. And 0.5, negative 0.5 plus 2 is 1.5. And then 5 divided by 1.5 is 3 1/3. So minus 3 1/3. So 8 minus 3 1/3, is that greater than 0? Yes. So the other part of the solution's in here. So to write this answer, the others do not check. To write this answer, it would be x is less than negative 2, or negative 1 is less than x is less than 0 for the conjunction, or x is greater than 3. So this is how complicated they can get, which is why you need to make sure that you check on the number line. Okay, so basically summarizing, get everything to 0, simplify the fraction on the left-hand side as much as possible, get your critical points, put them on a number line, and check the shading, and then use your graph to write your answer. Good luck.